All right, next let's look at some probability distribution. So again, probability is before things occur, so the probability that things will happen. So first of all, we need to look at random variable. A random variable represents a numerical value assigned to an outcome of a probability experiment. Now there are two types of random variables. First type we're going to look at is called a discrete random variable, and it can take on a finite or countable number of possible values. So for example, number of car accidents per year is just a finite number. The number of times you flip a coin, it's a finite number. So it's specific. You can count them 1, 2, 3, 4. Or you can have a continuous random variable. And this can take on an infinite number of possible values within a specified interval because it's driving. So you could drive a half a mile, not just 1 mile. So it's continuous. When you slam on your brakes, where did you end at? It could be 2.39862. So there's an infinite number of possibilities. It's continuously going. So let's just look at these two examples. We're going to classify each as a random variable or as discrete. Each random variable x as discrete or continuous. So x represents the number of times a phone rings before being answered. So the number of times it rings. You're counting the number. It's ringing once, it's ringing twice. This one's discrete. X represents the amount of time between when a phone first rings and when it is answered. The clock is continuously, if you hit a stopwatch, it's continuously going. So this one is continuous. So let's look at probability distribution. This one's a pretty familiar, that you toss a coin and you have two possible outcomes. So we're going to toss a coin twice. So the first time we could get a tails or a heads, and then the second time, so this was the first and this is the second, we could have gotten a tails or a head. So we need to make all of the possible combination. Tails with the tails, tails with the heads, heads with the tails, or heads with the heads. So our number of heads that we could have gotten 0, and that would have been 1 out of 4 possibilities. We could have gotten 1 head, and that would have been 2 out of the 4 possibility, or there could have been 2 coins that you flipped a head, and that's only 1 out of the 4. So our probability distribution would have been 0, 1, 2, and then probability that we get 25, 50, this way. And so there you go. So the number of heads that we could toss and then the probability that we would get that. So frequency tables are a good thing to be able to use. I really like them. So cars sold. I sold 0 cars, 1, 2, or 3. So a salesperson tracks the number of cars she sold during a 30-day period. Use the frequency distribution of the results to construct and graph a probability distribution for the random variable x, rounding each probability to the nearest hundredth. So first of all, there are 27, 28, 29, 30, which make sure it adds up to 30. There's 30 days, and they sold no cars. So that would be out of the 30, 20 out of 30, which is 0.67. 1 car would be 7 out of 30, which is 0.33. 2 cars, 2 out of 30, 0.07. And then 3 cars, it was 1 out of the 30 days. So this is a probability distribution. You're looking at the probability that if you randomly picked one of those days, you would pick whatever day. So you can still use probability on data that's been, and your probability that you would just, if you randomly picked one, that you would get that. So probability distribution. We're going to go by 0.1, 1, 0.2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 0 would be somewhere in here. 0.33, 0.07, probably a little high, 0.03. So that would be my probability distribution. So if we want to find the mean of a probability distribution, to find that mean, it will be the average of that probability distribution. We're going to multiply each of the values of x by its corresponding probability and then find the sum of the products. So that's given by this variable mu. And so the sum of each value of x times the probability that occurred. So this is a great way to look at data that when you go and you take a survey and they're like, is this really good? Is this not good? You're going to go and find the mean for that data. So somebody asked to rate a movie, and 1 is bad and 3 is good, and so 2 is average. You're going to find the mean score and interpret its meaning in the context of the problem situation. So a rating of bad, 19% rated it bad. 2 is average, 0.22, and 3 is good, so 0.59. So 1 times 0.19 plus 2 times 0.22, it's probability, 3 times 0.59, and add all those up, it gives us a 2.4. So notice there's not a 2.4 on there, but it's in the middle here. So the movie's considered between average and good. It's not average, it's not good, it's right in the middle. It's a little bit more on the good side, or the average side, than good. Variance and standard deviation are the next two things that we're going to look at. And so to find the variance of a probability distribution of x, we're going to subtract the mean of the probability distribution, which was that mu we just found, from each of the x values and square that difference. So x minus mu squared, which means it's always going to be positive. And then we're going to multiply that difference by its corresponding probability. And then we're going to find the sum of all those products. And you're right, this can be very tedious. Get yourself a good chart and go with it. And so the standard deviation then, so this right here, this is squared. The standard deviation is just you take the square root of that value. So continuing with the same problem that we just dealt with, I had mu was equal to 2.4. So same thing. We want to find the variance in the standard deviation of the probability distribution for the movie rating in the previous example. So I found mu was 2.4. I'm going to take 1 minus 2.4 and square it. Sorry, that square's a little bit small. And multiply by its probability. And then 2 minus 2.4, square it, multiply by its probability here. And then 3 minus 2.4 times its probability there. Oh yeah, don't forget the square. Add all those up, we get a 0.62. Now to get the standard deviation, take the square root of it, it's 0.7874. Alright, taking this a little bit farther. If we want to find an expected value, the expected value, labeled e of x, of a random variable for a probability distribution is equal to the mean of the random variable. So what I just said was that the expected value is equal to mu. An open-aired restaurant on the beach loses $90,000 per season when the weather is rainier than usual, and makes $450,000 when the weather is normal. The probability of having weather that is rainier than normal this season is 20%. Find the restaurant's expected profit. So we're going to take this loss, and that'll be a negative 90,000 times the probability of a rainier, because 20% is the probability is rainier. So times 0.2. So x times its probability plus the profit, 450,000, times the probability that it's going to be normal. So that would be 100, or 1 minus 0.2, so that's 80%. And add those up, and that's your expected profit, which is the same thing as your mean. Binomial distribution. It's a probability experiment that has been reduced to only 2 outcomes, success or failure. So you only have 2 outcomes, heads, tails, which if you want heads, success; if you don't want it, failure. So a binomial experiment is a probability experiment that satisfies the following condition. The experiment is repeated for a fixed number of independent trials. They can't depend on one another at all. Each trial only has 2 possible outcomes, a success or a failure. The probability of success is the same in every trial, and the probability of failure is 1 minus the success. So they don't have to be equal chances, but the probability has to be the same. And then find the random variable x represents the number of successes in trials. We're going to look at 2 scenarios here, scenario A and scenario B. And we're going to determine, first of all, if it's a binomial experiment. And if it is, we're going to state the number of n, which is the number of experiments, p, which is the probability of success, q, which is the probability of failure. List all the possible values of the random variable. If it's not, we're going to tell why. So first of all, the results of a survey indicate that 65% of couples have 2 or more jobs between them. A group of 50 couples were surveyed on whether they have 2 or more jobs between the 2 of them. The random variable represents the number of couples who have 2 or more jobs. So, yes, it's 2 or more. So they could have 2 or more, or they could have 1 or less between the 2 of them. So there's 2 outcomes, only 2 outcomes. So yes, it is. Even though they could have 3, 4, 5, 6, 7 jobs. That's not what it's asking. And so the number of people surveyed are 50 people. The probability of success, the results of the survey indicate that 65% of couples have 2 or more jobs. So probability of success is 0.65, and then 1 minus 0.65, that is 0.35. Listing all the possible values of the random variable, well, that's x. What could x be? Well, we could have had couple 1, couple 2, couple 3, couple 4, all the way up to couple 50. So x is 1, 2, 3, all the way up to 50. Now let's look at part B. We have 10 blue chips and 5 red chips are placed in a hat and shaken. 3 chips are drawn from the hat one at a time without replacement. The random variable represents the change of blue chips, represents the number of blue chips that are drawn. So remember, each time that the probability of drawing has to be the same. And since we did not put the chips back in, then the probability changes every time. So this cannot be a binomial experiment because the probability changes after each draw. So the probability of x successes in independent trials of a binomial experiment is p of x equals n cx p to the x, q to the n minus x. Now, you might be like, some of this stuff looks familiar. So it's the probability of x is equal to the combination, if we have n trials with x successes, and then the probability of a success to the power of the number of successes that we wanted, and the probability of a failure to the number of failures that we got. So this is success to number of successes, failure to the number of failures. And this is a combination, your NCR button in your calculator, or you can do that by yourself without using the NCR button. So lots of words, a lot of stuff that you have to pull out of these problems. A recent survey of high school seniors indicated 78% of students plan to attend some type of formal training or college after high school. So 78% plan to go to college. 4 seniors are randomly selected and asked if they plan to receive formal training or attend college after high school. Construct a graph and graph a binomial distribution for the random variable x representing the number of seniors who said yes. Then find the probability that at least 3 of them said yes. So in order to get each of these, all that I've done is that I've taken NCR, and there are how many people? 4 that we said. So 4C0. And a lot of people forget the 0. Don't forget to do if none of them said yes. So 4C0, success was 0.78 to the 0. And then 1 minus 0.78 is 0.22 to the 4. And that gave me 0.002. And I do that for each one of them. So 4C1, 0.78 to the 1, 0.22 to the 3. One thing to notice, 3 plus 1 gives you 4. But that gave me 0.033. And keep going. 4C2, again 0.78 to the 2, 0.22 to the 2, 0.177. Do that for each one of them. And then find the probability that at least 3, that meant 3 or more. So it could be 3 or it could be 4 said yes. So I need to take the 3 and the 4 and add them up. And so if I do that, I get 0.788. So almost 79% of them, the probability is 79% certain that at least 3 of them would say yes. The last thing we're looking at here is the mean and standard deviation of a binomial distribution. So for a binomial distribution, the mean and standard deviation. So the mean, variance, and standard deviation of a random variable x has a binomial distribution are given as follows. So mu is equal to n times p. Remember, p is the probability of success. Now, this formula for these, okay, they're different formulas, but they are equivalent to the ones that we've just found. So if you forget them, it's okay, but this is actually their easier formulas. So this is just the number times the probability of success. Oops. Erase. And spell success correctly. And then we have the variance, which is the number in the sample times success times failure. And then standard deviation, still take the square root of the variance. So these are just easier formulas to use, besides going through all the other stuff. So this only works for binomial distributions. So finding the mean, variance, and standard deviation of the example problem we just used would be quite easy. There are 4, and the probability of success was 0.78. So that's 3.12. And so for variance, 4 times 0.78 times 0.22, 0.69. Standard deviation, take the square root of that, 0.83. That is much quicker than going through for your mean and using the sum of x times the probability of x.